Hello, everyone. In this video, I'm going to talk about what a catalyst is and how it helps to increase the rate of a reaction. So a catalyst is a substance that we can add to a reaction in order to speed up the reaction. So it's very specific to the reaction, and not every reaction has a catalyst. So some reactions with the help of a catalyst can happen faster. But one thing about a catalyst that we have to note is that a catalyst is not a reactant or it's not a product. It's actually a substance you add at the beginning of the reaction, and then at the end of the reaction, you can collect it. So let's say if we put in 5 grams of a catalyst at the beginning of a reaction, at the end of the reaction, you pick up that 5 grams. So all it does is that it introduces a new reaction pathway. And with the help of that pathway, it basically lowers the activation energy of a reaction and makes the rate faster. So to better understand this, we can take a look at the potential energy diagram for the reactants going towards products. So first thing you have to understand is the idea of what activation energy is. I'm assuming you already know, but if not, the activation energy is the minimum energy required for a reaction to take place. So for example, let's say if we have these reactants and they want to become products, they don't just jump from reactants to become products. What should happen first is that the reactants have to make it up here in order to make the activated complex or the transition state. So for doing so, they need to have a minimum energy, which is considered as activation energy. So once they have this minimum energy to make it up here, then if the orientation of the collisions are correct, then in that sense, they can start making the products. So that activation energy is very important for us. One thing about activation energy we have to note is that as the activation energy is higher, whenever the activation energy is higher, the rate of reaction is basically slower. So activation energy, the higher the requirement is, the slower the rate will become. So what a catalyst does is that it does not change the potential energy of reactants or products. So the reactants and products are still in the same place. What happens is that now the pathway becomes shorter. So this is a shorter pathway now. So as a result, the activation energy value is now shorter. So that's how the rate of the reaction becomes faster. So you have a shorter pathway with a lower requirement for energy, and therefore the rate of reaction can become faster. Sometimes catalysts can do it in one step. Sometimes it can actually do it in 2 separate steps or multiple steps. So I'll show you in case if there's the reaction is happening in more than one step. So for example, this goes up, like there's 2 steps, but regardless, what happens is that the activation energy of the overall reaction is basically shorter than what it was before. Another thing to note about a catalyst is that the catalyst does not change the value of delta H of the reaction or enthalpy of reaction. So delta H is the distance between the potential energy of the products and reactants. And as you can see, the value of delta H is still the same value. So that doesn't change with the help of a catalyst. Also on the right-hand side, I'm showing the Boltzmann-Maxwell distribution. I assume you already know what this distribution is about, but if not, just keep in mind that the y-axis is always the number of reactant particles, and then the area under the curve are all the reactants. So all these dots that I've put in black, they all are the reactant particles, let's say. And then on the x-axis, we have their kinetic energy. So we're showing which particles have high kinetic energy or which ones have low kinetic energy. And then towards the end, there's a green line that shows the activation energy. So basically what we're saying is that only so far these molecules, based on collision theory, have the sufficient kinetic energy to react. So these are the number of particles or number of, let's say, reactant particles having sufficient kinetic energy. And by sufficient kinetic energy is the kinetic energy that it's greater than or equal to activation energy. So these are basically the reactants that over here on this graph, we were saying that they can make it from here up to here. So these are the reactants that can actually react. Now, what a catalyst does is, as we said, because it introduces a new reaction pathway and it shortens the value of activation energy, so it's going to move the line of the activation energy for us. So let me show it in red. So what it does is now the requirement is changed. So now here's the new activation energy with the help of a catalyst. So now you can see that more particles now have sufficient kinetic energy to react. So now all these particles on the right-hand side of the activation energy line have sufficient energy to react, and therefore the rate of the reaction will become faster. Okay, so that was it for this video. I hope you enjoyed it. Hope to see you in the next video. Thank you.